Okay, so let's begin our robot agent script. So let's create a script called Reacher robot. And double click. Okay. And we have this Reacher goal test. So we need to copy paste some of this information in. So here we had start and update, but in the MLAgent, we don't use start and update. We use initialize, set on episode begin, and we have on action received. So let's first change this to MLAgent by using unity.mlagent. But this is erroring because we didn't import the MLAgent script. So we have to go to our package manager, go to our MLAgents, and we are going to use, I'm going to use 1.0.2 MLAgents. So I'm gonna scroll down to there and install. Okay, now if I come back, this is not erroring anymore. Great. So using unity.mlagents.sensors. So we just import these two classes, and then we are going to change this to inherit not the mono behavior, but agent. So this will be the robot Reacher agent. We are going to import all the joints. So we are going to say public game object pendulum A. We have 6 joints. So we are going to do for 6 times pendulum B and so on. So I'm going to just copy paste B, 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 B for 6 times A, B, C, D, E, and F. Okay, we're going to convert the read their rigid body component. So rigid body MRBA, rigid body of A. Do this for 6 times. B, C, D. So C, D, rigid body D, E, and F. And we are also going to make a public game object, and we are going to get the end effector. So end effector, the name is a bit long, so we are going to say hand instead. So it's similar. So if we have a grabber end effector, it's essentially a hand. So public game object, and we also need a goal because we are going to also control the goal behavior inside here. Also, before we do that, let's go back to our scene. So instead of inside go test scene, let's go back to our original scene. So in the scene, robot training scene. Okay, so this one from here, let's delete this Richard test go. So in the robot, we are going to have our robot new script attached there. So we can try to drag this Richard robot instead of Richard Go. So here, so in the robot, Richard robot. Okay. And if we save this, it's going to start ask for all these joins. All right. So yeah, let's add them. So the first one, we add 0, 1, 2, 3, 4, 5, and hand is, let me check, 5. Oh, sorry. So we don't really need J0. So we should add 1, 2, 3, 4, yeah, 5, and 6. Yes, because we don't have to really work with the first one. And then we are going to use the end effector as hand and the goal as goal. Yes. Okay. Okay, I think that's it. Let's go back to our script. Okay. So the first thing we need to do is use public override and initialize. So that is a class coming from, it's a method coming from agent. For here, it's similar to the start. So we're going to assign each of the rigid body that is coming from each joint. So say get component rigid body and assign that to our VA. So we do that for all of this. Control C, V, and for B, C, D, E, and F, B, C, D, E, and F. Let's make sure I don't have any mistake. Okay. And we will have a public override on episode begin. When we begin our episode, we are going to set their position and rotation as our initial state. So for that, we are going to refer to each of these joints in the Unity. So for example, the first one, so whenever we begin the episode, we are going to set their location as a new vector 3 on this exact location. So they started from 0F, 0.55 F0F. Yeah, but one thing we are going to add here is transform dot position. The reason we do that is because in the future, we are going to group this and make a lot of copy. So, so like this, if we make a lot of copy, we want them to follow the parent's position. So that's why we are just adding the transform position, which is the parent's position. Okay. Because currently the parent position is 0, 0, 0. If we make a copy and move it, it might become something else. So it's relative. Okay, so let's also set their rotation. Transform rotation is, let's check. Check the rotation is minus 90. Okay, so quaternion Euler minus 90F, 0F, and 0F. Okay, and the rigid body of the A has a velocity. Let's set it to be 0, so there's no movement. And rigid body, it also has a rotation angular velocity. So also set it to be 0. Okay, so that's all set for one joint. We have to copy this for 6 times. Okay, 1, 2, 3, 4, 5, 6. And I'm going to just change its name first. Then I'm going to change the parameters next. C, 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 D, D. F, F. All right, and let's go to the joint 2. Joint 2 starts from minus 0.15 F, 0.55, it's same. Okay, let's check the joint 3. Joint 3 minus 0.15, 0. And 1.375. Okay. Number 4 minus 0.15. 1.375. Okay, that is same. And this one is, so we just do it one by one, very carefully. Minus 0.15 and 2F. All right, and the last one, minus 0.15, 2.11. Okay, just check everything else. It should be 0 vector. Okay, great. So that's how you initialize and in the set the on episode begin. And we need to set the observation collector. So we are going to use public override void collect observations. Yes, we're going to delete this. And then we are going to sense all this information per joint. So say sensor dot add observation. We are going to add a observation of the first joints, for example, the position. Control C, Control V. But we are going to use local position instead. And we are going to also use that. So say sensor, add observation, and pendulum transform and rotation. So you can copy this, Control C, Control V. Here, sensor, add observation. We're going to add the velocity. We're going to add the angular velocity, sensor, add observation, add the velocity. Yeah, so we do this for all 6. 1, 2, 3, 4, 5, 6, and just change the name. A, B, C, D, E, F, okay. And finally, we are going to add a few more observations. Sensor dot add observation. We're going to use goal transform position, local position dot local position. And we are going to also use the hand position, sensor add observation, hand, which is the end effector, transform local position. And sensor dot add observation, we are going to also use the goal speed. Okay, we didn't import the goal parameters yet. So I'm going to pause this here before we bring all the goal information. All right. So that's when, after you observe it, we are going to also receive some information. So let's set that up first. Yeah, public and override on action received. When we receive these actions, we are going to add a small torch behavior for each vector. So we're going to create a value called torque and math.clamp, and we are going to create a add a number to this vector action. So we are going to add the first action to range from -1f to 1f. And we're going to receive that and times this much number, and to convert that as a force to our rigid body. So we're going to add that as a force, add torque new vector 3 0f and torque that number that is received from the receiver. Yeah. Okay, and we are going to copy this, create another one with the second number coming from this system. And in this case, we're going to add the force on the Z direction for B. Okay. So Control C, Control V. For the second number, we add the Z directional force to C. For D, we use number 3 value and apply that force to Y direction. Let's copy, Control C, Control V. For E, we use the force number to apply to Z direction. So let's copy this. And then we copy this one and change it to F and do that. So 0, 1, 2, 3, 4, 5. So all 6 numbers we are receiving. And these numbers are exchanged to a bigger number by times 150 and added to the rigid body of each joint. Okay, so that's all set. But we just need to add the richer goal behavior. So we need to also integrate that. So let's go back to our script here. And let's copy and paste them in the correct position. So first one, let's Control C all of these and put them outside here. But this we don't need it because we already have it. So let's say these are all the parameters that we need for goal. All right. Okay, so, and then we have this set parameters that has been called in the start, right? So we need to have that copied, Control C. And let's copy that under here. Doesn't matter where, actually. And we have to think, well, where this is called, because this was called in the start. So it's similar to have this called in the initialize. And this also has to be called and on every episode. So you need to call this 2 times. Okay, and let's copy this one, update goal position, Control C, and let's put this all the way down. Let's think about where this should be called. And this should be called similar to the update. It should be called not in the collect observation, but on action received. So whenever you receive an action, it means you are updating your behavior. So you wanna update, Control C, Control V. You wanna update your goal position. And while you do that, you should also update your goal degree. So on every episode. So this will be run every time. On action received. Yes. Okay. So So that's it. You can also call this one inside on episode begin. So you can set all the parameters, but you can also update it one time. It won't change too much, but it's like, do you update it in the start or not, right? So you can call this one here. It's optional. It adds one more generation or iteration, and then you must call this here in on action received. All right, and let's add just the last observation. We are going to use the go speed, and we are going to observe that as well. Okay, I think we are all set. So let's save this. Let's close this script. Let's go back to our robot agent. And here we should add few things. We should add behavior parameters for the MLAgent. So it says there's no model for brain, it's okay. And before we run this, we also have to add decision requester. Okay. All right, and let's set this parameter to 4,000. And this behavioral name, we are going to set it as robot reacher. And then we are going to say continuous. And let's calculate how many observations we are receiving. So here, so we are receiving these many observations. So let's calculate this. So for this, we have 3 number is a location, and rotation is quaternion. We have 4, we have 3, and 3. So 13 times 1, 2, 3, 4, 5, 6, and 13 times 3 times 6. And then we have 3 and 3 and 1. So that is 7. So if we add up all of this, is 85 observation. All right. So that's why we are going to set this as 85. Okay. And for model, we don't need model for now because we are going to train. And how many observations are we receiving? So we are receiving 6 numbers. Where is that? Is here. So on action received, we are requesting 1, 2, 3, 4, 5, 6 numbers. So that's the number that we are receiving. And continuous, if you say continuous, we are receiving a number that has decimal number. If we say discrete, it's a number from either 0 or 1. Okay, at the end, we have to add something to our goal. So in the goal, we have to use, we have to set that this is a trigger. And we also have to set set something to this goal so we can detect whether this is touching the hand, the end effector, and to give some reward to this ML agent. Okay, so let's create another script called reacher goal. Let's add that to our goal. Reacher goal. Yes, and then double click. Let's delete. We don't need start and update. And let's have public game object agent, which is the robot, public game object, hand, which is end effector, public game object, go on. We are going to trigger the blue ball. So we are going to say void on trigger enter. So it means so you have to have the goal. So say it's is trigger, so you can actually test their position. Test when other collider is actually colliding with this guy, and then whenever something else is entering this ball, we are going to check if that is the hand object. So other dot game object is the hand object. We are going to let this goal transform local scale to be bigger. So slightly bigger so we can actually see it. So Control C, Control V, yes. Okay. We don't need to say private, yeah, but it's the same thing. Default is private, yeah. So on trigger exit when the trigger is out, you test this again. So if blah blah, make sure you close the parentheses correctly, and then the goal when it's exit, the transform goes back to the original. So we can set it to be 0 or anything smaller than 1. So originally we set it as 0.95. So we're going to put it back, and then similarly void on trigger stay. And if the hand is staying within this ball, we are going to give the agent some award. So agent get component, reacher robot. And we are going to, because that is the ML agent, we can add a reward. And we are going to give a little bit of reward every time when it stays inside. So it starts to learn. All right, so that's great. It's all set. And let's play it and see if it works. Obviously, this is not really testing. One thing I want to see is whether when this guy comes in, if it's going to trigger. So one thing we didn't add is these guys. So we need to add the agent. The hand is the end effector, and the goal on is this goal on. And we need to trigger this guy to test whether there is a collider. So we will need a mesh collider in the end effector as well. So we are going to add a simple box collider and make this one small. Something like that. Yeah, let's move this a little bit up. Yeah. So whenever this touches that, this will trigger. Yeah. And gives a word. Yes. So let's, yeah, I think that's it. That's all about setting it up, and let's play it. Okay. Great. So now what we want to do is we also yeah, so let's make this into a prefab as itself so we can make a copy of it. So we are going to make a folder called prefabs and right click, create a say training area. And then we are going to move these guys under here. And we are going to move this, bring this into here so it becomes blue. So it becomes a prefab. So whenever you want to make changes, you need to go inside here to make changes in order to affect the overall scene. So, okay, so let's check if everything is correct. We have 85 continuous default. Okay. Okay, so I'm going to copy many of this. Yes, and we are ready to train.